Hey guys, in this video, what we're going to do is we're going to create a program, and the program will take in a decimal fraction and convert it to binary. So let's go ahead and get started. First, we're going to include our standard input-output.h library. Let's create our main function, main. I'm going to put void here so we don't have to return anything. And what we want to do is we want to have a print statement. We're going to say, please enter a decimal, or please enter, a decimal number, and I will convert it to binary. So \n, semicolon, and now we need to tell it what to scan in. So I'm going to create a double here, and I'm going to call it the decimal number that we want. Call it decnum, and I'm going to do a scanf. So %lf for long float, because that's what a double is, and it's going to take in the address of decimal num. Okay, and then I'm going to do another print statement, and I'm going to say %lf converted to binary is another %lf. And the first one will be decimal number, and the second one, I haven't created this variable yet, but I will above this statement, and we'll call it decimal num converted. Okay, and so let's go ahead and create that as well. So double, I'm just going to copy and paste that here. Oh, convert it. And for now, I want to give it a value. It's like 0.0, just so we can see that all this is running properly. Save it as a .c file. Call it decimal fraction to binary. Okay, please enter a decimal number, and I will convert it to binary. So enter 0.625, and 0.625 converted to binary is 0.0. Of course, it's not, so we have to actually convert it ourselves. So to do that, let's declare a function. So this function will return a double, because a binary number such as 0.625 converted to binary would be 0.101. So we need a double. We need a place after the period. We need places after the period. So I'm gonna call it double decimal fraction to binary. Okay, and what it's going to take in, it's going to take in a double called decimal number. Let's go ahead and copy this, and down here let's implement the function. All right, so let's go ahead and give this a run. You can see, please enter a decimal number, 0.625. Okay, 0.625 converted to binary is 0.0, but we actually wanted to convert something, so let's copy this portion, and let's set our variable called double dec number converter. That's going to be equal to the value that we return from our function. Now this should give us an error because we haven't returned anything here in the function. So let's see if we do. 0.625, and it didn't. I am surprised. It might be this new version of this newer version of Dev C++. So what value did it return? Let's see, 0.625, and it gives us, okay, 0.625. So it says 0.625 converted to binary is 0.625. But this time, let's return a value. Let's return 1.7, just some random number, and let's see if it works. So type in 0.625, and now we get back 1.70. Okay, so that's good. Now we have to actually do some real converting. So how does the decimal to fraction work? Well, let's give an example here. So if our decimal number was equal to 0.625, then what we want to do is we want to take 0.625 and we want to multiply it by 2. This will give us some number, 1.25. And then what we want to do is we want to take the remainder of 1.25. So 1.25 mod 2. So that would give us 1. And that's going to be our first number behind the decimal place, our first binary number or binary digit behind the decimal place. Okay, but we're not done yet. So next, we want to now take 1.25. We want to subtract the remainder. And then we want to multiply that by 2. And this will give us 0.50. And then we take 0.50 and we mod it by 2. And we get 0. And we're still not done yet. Now we want to take 0.50, subtract it from 0, multiply it by 2. This will give us 1.00. And because we hit this 1, because we get this 1 here, we know that we're done. So this would be 1.00 mod 2 equals 1. And we're finished. So notice each time I'm subtracting by the remainder here. So I get 1, I get 0, and I'm just going to stop it when this value here is 1. And then, so this tells us that 0.625 converted to binary is, we have 1, 0, 1. So it's 0.101. Okay. Now something to note here. 0.101 is equal to 1 times 10 to the negative 1 plus 0 times 10 to the negative 2 plus 1 times 10 to the negative 3. And so we're going to have to also use that in our loop here to get this nice decimal number here. Okay, so let's go ahead and write this. So I'm going to create a double. I'm going to call it current number. And current number is going to be equal to our decimal number times 2. So in the case of 0.625, our current number would equal 1.25. Okay, and we're we're going to need to get our remainder. It's going to be a double remainder. And our remainder equals the current number modded by 2. Now the only thing is, when we're doing modulus, we're going to need to cast the current number as an integer. So that's what I'm doing. I'm just casting it as an integer. Maybe I need to put parentheses here and here just to make sure that this current number is being casted to an int. So if, again, our current number was 1.25, as an integer, it would just be 1. So we have 1 mod 2, and that would give us the value 1. Okay, we need to check, we need our base case. We need to check if our current number is equal to 1. Because if our current number is equal to 1, remember that this is our current number here, 1.25, 0.50, and then 1.0. So if it's equal to 1, then we know that we're done, and we can return a value. And what are we going to return? We will return the remainder times. Now let's see here. Again, we need the third place of our binary digit. So if this is the last one, in the case of this 0.625 here, that last number is going to be 1 times 10 to the negative 3. So we're going to need something called the power function, and we're going to need to know how to put 10 to the negative 3 here. But 10 to the negative 3 is a specific case, so we're going to need this to alter, and we're going to need this power function here. So let's go ahead and include math.h, and in here we have the power function, which takes in 2 doubles, we call it double x and a double y, and returns x to the power y. And we're going to need this 3 here, again, to keep decrementing. So we're going to need a negative 1 here, a negative 2 here, and then we're going to need a negative 3. So that means we need to change our function. Taking an integer, we'll call it k value. And here I've taken integer k. And then when we use it here, we have to take in some value. Seeing as how it starts from negative 1, it's going to always start right here, the 10th place. Then we can always initialize this function with negative 1. Okay, and then I can always put k here now. So that means that our k value is going to have to keep decrementing. So if we get to the base case and we're not done, if the current number does not equal 1, then we need to return the remainder times the power of 10 to the k plus, so remember this is our remainder times 10 to the negative 1 for the first case, plus, and then we're going to return whatever else we get from our function. So we're going to put in current number minus remainder, and then we're going to decrement k 1 time, and then semicolon. And so now what I'm doing here is I'm returning the current number minus the remainder. So I'm returning this value here, and our k value decrements by 1. So now instead of it being -1, which it was initially from the -1 we put in here, if we go to this next step, it would be -2. So let's go ahead and run through. Let's run through the program. I'm also going to put recursive case here. So we have our base case, we have our recursive case. I think we're pretty much done. Let's run through. So my function is going to take in 0.625. That's what the decimal number is going to equal. Our integer value k will be -1. It's going to always be -1 initially. Okay, so we do 0.625 times 2, and that's what we get. Our current number here is equal to 1.25. We take the remainder, 1.25 mod 2. So 1.25 mod 2 is here, that's the remainder, and we get 1. Now, does 1.25 equal 1? That's what we check here, and it doesn't. So we don't go to this base case. We go to the recursive case. And what we have is, we have our remainder, which is 1 times 10 to the -1. And that's what we have here. And then we're going to add whatever this returns. So far we have 1 times 10 to the -1 plus, and let's see what this returns. So now we're putting in current number minus remainder. That's our current number is 1.25. Our remainder is 1, so we get 0.25 is what we're inputting here. And now our k is -1. So our k was initially -1. So that's going to be -2. And so we get our current number is equal to, again, 1.25 minus 1 is what decimal number is, times 2.0 gives us 0.50. Our remainder is 0.50 mod 2, which gives us remainder 0. We check to see if the current number is equal to 1, and the current number is 0.5. So it's not. So we go to our recursive case and we say our remainder, which is 0, 0 times 10 to the -2, because our k decremented by 1, plus, and we have this function again. So this is going to be now 0.5 minus 0, and our k decrements by 1 again, and right now our k value is -2, so it's going to become -3. We go through here again, we get 0.5 times 2, we get 1, and then we get 1 mod 2 is 1. So the current number is 1. So now we get to our base case finally, and we return our remainder, which is 1 times 10 to the -3, 1 times 10 to the -3, and we're done. And we go back up, and now we add 1 times 10 to the -3 plus 0 times 10 to the -2 plus 1 times 10 to the -1. So, let's give it a run. So we're enter 0.625. Yes. So 0.625 converted to binary is 0.101, which is great. So that's exactly what we wanted. That's exactly what we did. So now to finish off, there's a few issues here with what we've done. The first issue is we didn't check to make sure that they're inputting a fraction. So if they input something like 1, let's see what happens. You see that my program stopped working. And if they input a number such as 0, again, you see my program stop working. So we have to make sure that they only put in a fraction. So let's create a while loop to make sure the user only inputs a fraction. So I'm going to say while our decimal num is greater than or equal to 1, and our decimal number is less than 0, let's printf, please enter a decimal number. And let's rescan. Oops. Let's rescan for that number here. So let's see. So I put in 1. Oh, so I think I put and here, and it's supposed to be or. So now let's run it. Point. Oh, let's just do 1. Please enter a decimal number, 0. And let's see, it should be less than or equal to 0. So let's try it again. So we have 1, 0, good. -4, 3, good. So now we're making sure that we are inputting a decimal number. Let's see here. There's one more thing, and I think that my compiler is actually going to accommodate for it. But if I have a decimal number that would cause an infinite binary number, such as 0.2, this is actually not the binary number for 0.2. This is a rounded version. So what that means is that this 0011 repeats over and over again, but it looks like my compiler here accounts for this. But if yours does not, then what you can do is you can create another base case. You can say if the current number is equal to 1, or current number equals original number, then we do that. And the original number I haven't created yet. Let's see. I'm going to make it a global variable. And I'm going to set it here. Original number is going to equal the decimal number. And to make sure that this works, I'm going to do a print statement. Well, I'll make 2, just in case. So one base case will be for what we need, and the second one will be just to print repeated. So let's see what we get. Let's see, it says printf. It needs a semicolon here and a semicolon here. Run it. 0.625. So we get that, which is good. And now for the repeated number, 0.2. Looks like it doesn't go there. And let's try 0.1, another repeated number. But this should handle that case as well. So thank you guys. I hope this video was helpful, and I'll see y'all in the next video.